Hello developers, let's start developing. Today we're gonna take on the 7th task of the 2024 Advent of Code. It's a bit later in the day, so I took the liberty to read it. Sometimes the weekend ones are kinda hard and today is Saturday, but this kinda looks okay so far. So the story is bonkers as usual. We have some bridge calculations and a group of young elephants stole our operators, which means we don't have the operator that should be here. Fortunately, we only use two operators, adding and multiplying, and we need to verify which of these statements are possible. So, of course, this one is possible because if we multiply these two together, everything is fine. This one has two different solutions. This one is, of course, impossible. There's just no way to get to that. And so on and so forth. So we have our puzzle input. Some of the inputs are quite biggish, I would say, up to 10-ish numbers. But anyway, let's start with the small input. Let's see if we cannot solve the initial task, then we most likely cannot solve the other one. So let's start doing stuff. Let's start typing our input. So our input will be an array of things, and each thing will have a target, or what is actually this? It's equation. It has a target, which is a number, and it has a set of parameters. Before the remaining numbers, they're called numbers. Let's just call them values, and that is a number array. So we're not gonna be taking on a string array, we're gonna be taking on an equation array. So now our process input kind of fails. I will turn off part 2 and the result 2 so that we can just take the first result, and now we're gonna need two equations, no equations, lines.map. For each line we're gonna need to do some processing in order to get an equation. So it says something like this. Of course not. First of all, we need to find the single column. Let's split on a column. Actually, let's split on a column space, since that is the separator. So that means that this will be the first element and this will be the second element. And then, yes, something along these lines is gonna be the first thing, the target. And we have our values, parts dot slice 2. No, we're not gonna do that. So we have all the parts, and we can have parts of 1. And then we're gonna split on a space, and for each value we're gonna parse int that value to a number, and we're gonna return that. So yeah, kinda makes sense. We're gonna return the equations. One other property of this mini framework that I built that I'm not using too often is that I can actually run it in debug mode, which will automatically show the input. So I will leave this as it is, and just let's see if the input is parsed correctly. So the first one, the target should be 190, and we have two values, 3267 and 3 values. The last one, 291, 4 values. Seems like our parsing is quite okay. So that makes sense. By the way, I also have a method called the log that we can use to write some code. Yeah, we need to import it. So this will only show if I'm debugging something. If the debug environment variable is true, I'm debugging. And if I just run start without the debug, that part won't be shown. It's easy. It's useful when we want to play around with some ideas. Anyway, we have our equations. So now those are kind of independent. So we will have something like let result equals 0. And what we need to do for each equation of the equations of the input, we will need to basically get the value. Actually, we can just check the value, because if the value can be achieved, check can be achieved for that equation. And this says let's add some other values. So actually, let's write the skeleton of this can be achieved method. So what I want something like this. I want to have the target, but I also want to have an accumulator, which will be a number. And I will want to have the values. So note that the first number, some of the constraints that we have, I didn't mention this. The numbers have to be in order, and we are not actually allowed, the adding and the multiplying doesn't use parentheses, so we're using the calculator precedence. So once you say 16 plus 10 times 13 is 16 plus 10, 23, times 13, 26 times 13, it's as much as it gets. So they're explicitly left to right evaluated. Just like if we are entering them on a chip calculator. Once you say 16 plus 10 times, it will automatically calculate 16 times 10 and then continue on. So the first number will always be included. That is the starting accumulator. These are the rest of the values that we're gonna use. So I'm gonna be doing something like that. So I will basically, first of all, don't need the equation, we need the target and the values. So now we have the target, but the values I want to kind of split. I want to split the values into the first element and everything else. And now I'm gonna call can be achieved using the target, the head, and the rest. And can be achieved basically returns a boolean. Let's imagine that it only returns false. And now our code will be if it can be achieved, then we just result plus equals target. We just add the target to the result. That's all the code that we need for part 1, except the tiny detail that we actually need to implement can be achieved. So, can this be achieved? The reason why I did this signature, because I think that we can solve this using recursion. And since we only have two options, adding and multiplying, so basically I will try them both on everything. So I will do something like this. First of all, the most important thing when using recursion is to set up a nice terminating value so that can be sure that the recursion terminates. So in each step of the recursion, I will be taking a number out of the values and somehow applying it to the accumulator, which means that the values array will get one element shorter and shorter and shorter in each run of the recursion, so which means it will eventually become empty. So we can say if the values.length equals 0, then we have a terminating condition, and it's exactly this. If the accumulator is equal to the target, we're done. If the accumulator, if we're done, we're returning true. If the accumulator is different from the target, we're just gonna return false, because it cannot be achieved this way. Otherwise, yeah, from the values, we're taking the first element. And now we're just gonna do. Yes, we're actually gonna do exactly that, but I'm gonna be more wordy because this is kinda ugly. So, we will just handle addition first. Not addition, handle addition. And we're gonna do something like this. So, the target stays the same, the accumulator changes by adding the head to it. The rest is the rest. So note that the rest has one element less than values. If this can be achieved, return true, otherwise return true, otherwise return false. Note that if it can be achieved in any way, we're just returning true. So if it can be achieved by addition, we're golden. We don't need to check multiplication. Same thing for multiplication, only that's everything we have. And that should be it. Recursion is terribly elegant if it works, but we need to make sure that we have a proper thing. So we are basically changing the question using recursions into, if we take this number and apply everything to the rest, can this target be achieved? Looks weird, but it could work. Let's see. It says that the result for the sample input is 3749, which is exactly the correct one. Let's try it on the bigger input. I'm quite freaked out. Which is the biggest number here? Actually, let's write some more code. Or let's hope for the best, and later I'll explain why I was kind of worried. It says that the result part 1 is this huge number. Great, on day 7 we got into the huge numbers, and that's the correct one. That's good. The problem is that JavaScript, which is basically what I'm running my code on, since I'm writing in TypeScript and gets done in JavaScript, is not very good using numbers. Basically, integer math is correct up to a point. We only have the number type. So whatever we do, it's always gonna be a number. So 1 is a number, and 0.0 is a number, and 1,000,000 is a number, because we are actually only have real numbers. But it's kind of optimized and it's done up to a point. So 1 plus 2 actually gonna be always be 3. It's not gonna get rounded down. If I'm working with integers and having operations that produce integers, I will get integers. Again, up to a point. To what point is that? That is this point. we have a value called max safe integer. So it's guaranteed that anything that's less than this value will result in a correct integer operation. And usually advent of code creators take that into account. So if we have numbers that are above that number, we're kind of screwed, which means that we're gonna have to use something else, some other technique, and not just regular addition and numeric operations. But this case we got lucky. Actually, we got pandered to because the creator of Advent of Code actually made sure that the numbers are big but are less than this huge number. Let's continue on to part 2. The engineers seem concerned the total calibration results you gave them is nowhere close to being within safety tolerances. Just then you spot your mistake. Some well-hidden elephants. Oh, some elephants have a third operator. And that operator is the concatenation operator. Yep. Okay, we have a concatenation operator. Now, the problem is recursion. Now, it seems that it's gonna be simple. I will rename this function can be achieved 1, can be achieved 1, which means that we can just need to implement another one, which is can be achieved 2. And now we are kind of fortunate since we're working with JavaScript, since JavaScript is sufficiently freeform. So what I'm about to write will be kind of performant and kind of operational. In any other language there are better solutions, but I will literally just copy the code from part 1 into part 2, only I will call can be achieved 2 here. And we need to make sure that we're actually calling itself and not its brother above. So handle concatenation. Yeah, and this time actually it guessed correctly what I want to do. So I will turn the accumulator to a string and turn the head to a string and just mash them together using a plus operator as strings, and then I will turn that into an integer. And I'm quite sure that this will work for the second example, for the small values. No, it doesn't. Did I save? Yeah, that was the problem. My code runs better when it's actually saved. So we have 11738. That's cool. Let's see if this works for the bigger input. But the problem is that recursion is extremely dependent on some factors. Basically, we have something called a fan-out factor, which means we enter a recursive functions, how many times do we call it inside it? It used to be 2, now it's 3. And we also depend on the depth of the recursion. Since if we have an element in the regular input, the most we do is 1, 2, 3, 4, which means that the depth is up to 4. But the total number of calls, which will be actually 2 to the fan out to the exponent of the depth. So it will be this 2 to the 4th. So we had something about 16 possible options, but see how much it is if the first number is 3. Everything is great, but what happens if we have factor of 2 and 3, but this is not 4, as it is in the smaller example. This is a bit more like in this example when we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items. So we have the power of 12. For 2 is just 4,000 options. For 3 it's gonna be a lot more. It's gonna be 500,000. So this is not a big number. Basically anything up to 1 billion is doable on a modern computer. But you can see that if the fan-out factor was not much bigger, if the fan-out factor was 5 and we have 12, then this would get to be a huge number. And if the fan-out factor was something like 8, this is getting unmanageable. Let's just format this so that we have like a number, 1,000 separators, we don't need decimal places, so this is 68 billion. And if this was 12 and we had 20 options, it's gonna be this number, which is not really doable on any kind of computers. And even if it was as low as 5, it's gonna be still a huge number. So it's very dependent on the fan out and the depth. But here we have, I guess, this much, so 500,000, it should work. I wanted to get a feeling of that number before I actually run the code, but now I will. I think it's running with the big input. Let's see what is the value that we get. Oh, you see that it took me 2.5 seconds. The first part took 31 milliseconds and this took 1,000 times more. And we just moved from 2 to 3. Let's see if this is actually the correct value. It could not be. I will paste this in Excel first to see how many digits I'm getting. So I'm getting 15 digits and we're golden. Why? Because max safe number is actually 16 digits, which means that we managed to be under that. I got quite scared for a moment there. And that is the right answer. So we did a minimal change to our code, but we had a nice little discussion about recursion. So thank you. If you liked the video, mash those buttons, subscribe, like, comment, and see you tomorrow. Keep developing.